We've looked at some of the drawbacks of monoliths, so let's look now at how microservices can help us. By breaking our application into smaller pieces, each microservice can be owned by a small development team and is much easier to understand and work on. A good rule of thumb for the size of a microservice is that it's small enough to be thrown away and rewritten if necessary. Microservices allow us the freedom to adopt new technologies without needing to upgrade everything in one go, and the flexibility to choose the right tool for the job. For example, one microservice might use a relational database to store its data, while another uses a document database. One microservice might be written in a functional programming language, while another might use an object-oriented approach. Of course, there are still benefits in using standardized approaches where possible, but there's no hard requirements. Individual microservice development teams have the freedom to use the most appropriate technology. When we create microservices, their loose coupling means that we can deploy them individually. And this is a huge benefit since it's much lower risk than upgrading everything in the entire system in one go. And it also helps us to achieve zero downtime deployments. And that's because while we're upgrading an individual microservice, it's quite possible for the rest of the system to carry on running. Microservice architectures enable teams to deploy with much greater frequency. Rather than waiting months between upgrades, as is often common with monoliths, changes to individual microservices can be pushed to production as soon as they're ready. And it's even possible to deploy microservices multiple times a day. Microservices give us much more control over scalability. We can scale out each microservice individually, which is much more cost-effective than scaling a monolith. Finally, microservices make us more agile. We can adapt more rapidly to changing business requirements. By keeping our microservices lightweight and decoupled, they're more easily adaptable to use in new scenarios. And these are just some of the reasons why microservices is becoming popular, particularly for very large cloud-deployed systems. But unfortunately, microservices do come with some challenges of their own, so let's look at those next. If microservices are so great, then why don't we just use them for everything? Well, it's not a free lunch. There are some things that can be more challenging with a microservices architecture, and it's important that you understand this in order to decide whether microservices is a good fit for your application, and also so that you can be prepared to deal with these challenges as they arise. One of the first challenges you'll face is how can you ensure developers are productive working on the system? Do they have to download the code for every single microservice and run it individually and configure them all to talk to each other? That could be very error-prone and time-consuming. You also need to have a way of working that enables developers to easily work on an individual microservice in isolation, as well as testing their microservice in the context of the whole application. And we'll be seeing some ways to achieve this later on in this course. If we break an application up into dozens of microservices, then there's potential for the interactions between those microservices to get very complex, making it hard to understand the behavior of the system as a whole. And it can also lead to performance issues. If you don't take care, you can find that a single operation requires lots of inefficient verbose communications between many microservices. And while deploying an individual microservice is a smaller and safer task than deploying a monolith, when you have many microservices, automated deployment becomes critical because you're going to have many more deployments to do. Finally, if there's a problem in production, we don't want to have to connect individually to every single microservice to examine its logs and work out which one is the cause of our troubles. So it's essential that you have a great monitoring solution, enabling you to view logs and telemetry for all of your microservices in a centralized place. The good news is that there's a growing body of tools and practices available to help you succeed with microservices and overcome these challenges. And we'll be learning about many of these as we progress through this course. Now, I don't want this course to be purely theoretical, so we're going to be referring to a real microservices application as we go through this course, which will illustrate the principles that we're learning about. And rather than me spending a few months creating my own microservices application, I've decided to use a pre-existing reference microservices implementation called eShop on Containers, which is open source and available here on GitHub. And there's a few reasons why I picked this example to use in this course. First of all, e-commerce is a well-known problem domain. We've all used a shopping website, and so it should be fairly straightforward for you to understand what the responsibilities of the various microservices, such as the basket, catalog, and ordering services are. But it's also a non-trivial example. As you can see from this system architecture diagram, there are 3 client applications, 2 websites and a mobile app, and 6 microservices, making use of a few different database technologies and communicating via an event bus. And this sample also makes use of a pattern known as an API gateway, or back-end for front-end, that we'll discuss later on in this course. It's also being actively maintained, and it's regularly updated with newer technologies and practices. In fact, it's had 96 different contributors at the time of recording, making it representative of what it's like to work on a real-world microservice system where you have many developers collaborating together. It's also containerized, which means it's really easy for you to run the code on your local development machine if you want to try it out. And there are detailed instructions provided on GitHub explaining how to run it locally, whether you're Windows or Mac based. Finally, it's very well documented, including a couple of excellent free ebooks that you can download to help you fully understand the architecture, and they give the rationale behind many of the decisions that have been made in this project. And that's important because even if you choose microservices, you're still going to have a lot of choices ahead of you. Microservices don't dictate what programming language you use, what type of database you'll use, whether you communicate synchronously or asynchronously, or what authentication mechanism you're going to use. And that means you're completely free to pick the ones that you're most familiar with and meet your needs. And we'll be discussing some of the factors that will help you make these decisions as we progress through this course. By the way, don't worry too much about the specific technology choices in the sample eShop on Containers application. Because it's a reference application produced by Microsoft, it uses the .NET framework and has scripts to help you deploy the application to Azure. But it doesn't matter if you're not a .NET developer or you use a different cloud other than Azure. We're going to be focusing in this course much more on the overall architecture rather than on the specific technology choices. So you'll have no problem following along if you prefer to write your code in Java or Python, or you like to host your applications in AWS or on Google Cloud Platform. Let's wrap up what we've learned so far. In this first module, we learned about what a microservices architecture is and how it differs from a monolith. We've seen some of the benefits as well as challenges that microservices can bring, and in our next module, we're going to start looking at how we can architect a microservices solution.